a manager is comparing the cost of buying ball caps with the company emblem from two different companies. Company X charges a $50 fee plus $7 per cap. Company Y charges a $30 fee plus $9 per cap. For what number of ball caps will the manager's cost be the same for both companies? All right. A lot of you guys can probably think through this kind of maybe logically and just kind of have that kind of sense. But I'm going to try to kind of show you kind of the mathematical part of this. And what I would do, or this is kind of solving a system of equations. That's the type of problem this is. Meaning I have two equations, right? I'm going to have an equation for company X and I'm going to have an equation for company Y. But we're looking for where the cost of them is the same. Well, same means equal, right? So we're going to figure out where those two are equal to each other. So I'm going to set up an equation for the first company, right? Company X, they charge a $50 fee plus $7 per cap. When you see this 7 per cap, that should ring out, that's rate of change, right? That's our slope. It's per something. It's changing. Every time we sell a cap, that changes, right? Or that increases how much they charge, but it's staying the same. It's 7. This is a linear equation, and so right up here, maybe it's 7. Maybe call it C for caps. You could call it X. You could call it whatever you want. Plus $50 fee, right? That's the equation for the first company, because they always charge $50, right, to begin with, right? But that has nothing to do with the caps. So that's kind of like a fixed cost, or that's your y-intercept. That's your starting cost. For company Y, they start out by charging you $30, right? So that's just an extra, that's a fee that's going to be there no matter what. But then their rate of change, right, their slope is $9 per cap, okay? And so we want to see when these things are equal. 7C plus 50 equals 9C plus 30, right? And so I'm doing this by solving an equation. A lot of you guys might have just figured out what the different costs were for the company for these different amounts, since it's a multiple choice, right? And kind of checked it that way. But this works just as well. I'm going to move my C's together, so I subtract 7C from both sides. I get 50 equals 2C plus 30. Now that I've got the C's together, I'm going to try to get it by itself, start away from it. I'm going to subtract 30 from both sides. I get 50 minus 30 is 20 equals 2C. 2 times C, I want to divide by 2. C equals 20 divided by 2 is 10, right? So 10 caps, right? That's when the cost of both companies are the same. You could have made a table and looked to see where they were the same. You could even graph this. And remember, on a graph, I would have had two different lines. When I want to know where they're same, that's where I'm looking for the intersection, right? Where those lines cross. Number 17. A shop sells 1-pound bags of peanuts for $2 and 3-pound bags of peanuts for $5. If 9 bags are purchased for a total of cost of $36, how many 3-pound bags were purchased? Okay, you could, a couple of different ways of doing this. You could solve an equation, right? Set up an equation and solve it, right? But we can kind of think through logically and kind of narrow this down a little bit, okay? It's asking for the 3-pound bags. Remember, 3-pound bags cost $5, okay? They told us there's a total of, slide this over so you can see it. If 9 bags are purchased, okay, look at my answer choices. If 9 bags are purchased, how many 3-pound bags? You should be able to eliminate one of your answers right away. 18. They can't buy 18 3-pounds of bags if it told us they purchased 9 total, okay? Now, moving my way up the list, okay, if they bought 9 3-pound bags, which they can, they could have just bought 3-pound bags, 9 times 5 is 45. That means they would have spent $45. But in the problem, they say the total cost is 36. So that doesn't work either. So we can start narrowing these down. Now, I'm going to kind of just do that trial and error. I think that's the quickest way to maybe do this one. 6, okay? If they buy 6 3-pound bags, 6 times 5 is 30. They would have spent $30, okay? But it says they bought 9 bags, okay? Well, if they bought 6 3-pound bags, that means they bought 3 1-pound bags, and the 1-pound bags are $2 a piece. 3 times 2 is 6. So they spent $30 on the 3-pound bags, $6 on the 1-pound bags. 30 plus 6 is 36. So they spent $36, and that actually matches here, right? So that's B. So hopefully that makes sense. If you decided to set up an equation, your equation will look something like this. You have 36 is your total cost, right? So that's going to be equal to $2 times your 1-pound bags plus $5 times, well, how many times however many 3-pound bags. But I can't just put another variable in. I only want to keep one variable. And if B represents the 1-pound bags, 9 minus B equals the 3-pound bags. Again, it's 9 minus 3 because there was 9 total bags. So if I subtract out how many 1-pound bags there are, that would give me B. So in this case, B equals 1-pound bags. Right? You could also set up the equation a little bit differently. So, you know, switch the 9B and put that over here and the B over here, and then it'd be looking for the 3-pound bag. So again, this way works great, but if you like equations, that'll work as well. All right. 18. Which pair of inequalities is shown in the graph? Okay, inequalities, notice they have the shading, right? And things like that. And that's exactly what you want to do when you have inequalities and shading. But our different choices, what we want to come up with is kind of the equations for these different lines here, right? And so, easiest way to look, and you guys see their answers are in slope-intercept form, which means I need to pick out two things. I need to pick out the slope of these lines, and I need to pick out their y-intercepts. And so, this first line here, okay, it is, I'm going to pick out, first off, I can pick out the y-intercept is 1, positive 1. Okay, and so I'm going to maybe start by kind of maybe trying to see if I can eliminate any choices, but I kind of look through and I see all of these are plus 1, plus 1, plus 1. So they've got the correct y-intercept. So I need to kind of look at the slope of this line. Well, I already see that it's going down, so it's negative, right? When it's going down left to right, it's negative. And you can see it goes down 1 over 1. So it actually has a slope, right? Its m is negative 1. And so I go through and I see here, well, this is, remember, slope-intercept form, y equals mx plus b, right? Here's the b for that line. So it should be negative x plus 1. And so I can eliminate a couple choices here. I can eliminate b. I can eliminate d there. Okay, so that gave us this. Now if we want to look at this other one here, it doesn't carry all the way over to the y-intercept, but I can kind of see it's going to be down here in this negative 5 range, which, you know, that's what both of our answers are. But the difference between our two choices are this one has a positive slope, right? There's a positive 1 there, and this one has a negative slope. Hopefully we can see right away real quick, going left to right, that it has a positive slope, and you can see that it's going up 1 over 1. And so since it has a positive slope, our best answer is A, right? This one had a negative slope, so that's incorrect. Hopefully you guys follow that. It was, notice they used, try to erase that real quick just to point out a couple things, right? They used a dash line because it didn't have the equals to, they were just greater than. They shaded above because it was greater than, right? So you're shading above, and that's where they intersected the shading. So hopefully we do a good job there. 19. Which graph represents a system of equations that has multiple common coordinate pairs? Okay, common coordinate pairs, that means where they, in common, they have the same, it's where they intersect. And we want to see, where do these intersect multiple times? So if I'm going through, A intersects 1 time, that's not multiple, so it's not A. B's interesting, right? And you may think, oh, there's only 1 line there. They kind of show you 2 arrows, so you have lines on top of a line. Well, how many times does that intersect? Well, it intersects an infinite amount of times. It intersects everywhere. So B's the answer. B's our best choice. We see that it intersects here, 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 right, in all these different spots. So B's our best choice. You can kind of go through and see C would intersect only once, and D intersects only once. So again, B was your best choice there. It intersects an infinite amount of times. All right, last one we're going to do in this section, in this video. Number 20. Which graph represents the solution x is greater than 3? Okay, notice all of them pick up on 3. It just says greater. It doesn't have the line underneath. It doesn't mean equal to. Okay, so that means it needs to be an open circle. So we can go ahead and eliminate A, and we can eliminate B, because they had closed circles, and that would only be true if it was greater than or equal to. Now, so I'm choosing between C and D. X, right, it's greater, it's opening up to the X, it wants to eat whatever's bigger, you know, you can kind of think about like alligator. So what numbers are bigger than 3? Well, 4, 5, 6, 7, those are bigger, so our best choice there is C. All right. Hopefully you're continuing to work through this, the questions, hopefully this is helping you, and good luck.